Okay, good morning, you guys. We are on page 112 today in your notes packet. Yesterday, we started talking about standard form for linear functions. We looked at all examples that had some sort of context or scenario to them, and we talked about how those particular scenarios typically lend themselves to slope, intercept, or point slope forms. So we talked about standard form. Today, we're going to talk just about graphing standard form. We did graph one function in standard form yesterday, but we already knew some points that were going to be on that line. So we graphed it by plotting points that we already knew were going to be on the line. Today, we're going to look at graphing if I don't already know some stuff about the graph. Okay, so we're on page 112 in your packet. I'm going to give you two options today for graphing. So we're going to go through a couple of examples together. I'm going to go through both options with each example, but once I turn you guys loose and say graph, you can graph using whichever strategy you like best. Does that make sense? So I'm going to show you two as we go through example problems today, two different ways that you can approach these. You can pick what you like best. Just keep in mind that for some functions, one strategy may be a little bit easier than the other. So we have at the top of page 112 our function that we're going to graph, and it's the same function twice here, so that we've got it sort of clean and nice and pretty as we look at each of these options. The first one that we're going to take a look at is taking our standard form function and changing it, rewriting it so that it's in slope-intercept form. So remember that slope-intercept form looks like y equals mx plus b. That's slope-intercept form. The big idea is that we want y by itself. If I have slope-intercept form, then y is by itself. So I'm going to take the standard form equation that I have right now and rewrite it so that y is by itself. So right now, I've got the x term and the y term on the same side. I'm going to move the x term to the other side. Since I have positive 2x, I'm going to move it by subtracting 2x from both sides. So this would leave me with negative 6y equals negative 2x plus 12. Be very careful with your signs. I also want to point out that I did not combine the 12 and the negative 2x. They're not like terms, so I can't put them together. Okay, they have to stay separate. And now I've got the y term by itself, but y isn't by itself. Right? It's got that coefficient of negative 6 hanging out in front. So I need to get rid of that negative 6. So I'm going to divide every term by negative 6. Okay, and not just both sides, but every term. The x term gets divided by negative 6, and that constant term of 12 also gets divided by negative 6. Everything's divided by negative 6. On the left side, we're left with only y. And then on the right side, I've got some simplifying. So here, negative divided by a negative will be a positive. And then 2 over 6 I could reduce to 1/3. So I'd have 1/3 x. And then 12 divided by negative 6 would be negative 2. So there's my slope-intercept version of this line. We started with standard form. We got y by itself to change it to slope-intercept form. Okay? Depending on the function that you have, this may be a little bit of work. It may be kind of a lot of work. Okay? Be very careful with your signs as you're moving things around and dividing. Once we have slope-intercept form, that's something that we know how to graph. Our y-intercept would be negative 2, so I can plot that. Our slope is 1/3. Remember, it's rise over run. So I'm going to go up 1 and forward 1, 2, 3. Up 1, forward 1, 2, 3. I could reverse that to get some points back here. Down 1, back 1, 2, 3. Down 1, back 1, 2, 3. How many points do you need to give me when you graph? 3. Always at least 3, I ask from you. And then once I've plotted those points, what do I need to do with them? Connect them, yeah. Once I've connected them, what do I need to do? Arrows on the end. Very good. So we have just graphed a standard form function by rewriting it in slope-intercept form to find the y-intercept and the slope. Okay. We have another option. So if this was not your favorite thing, there's another strategy that you can use. What we're going to do is find the x and y intercepts. Okay. So to find the x-intercept happens here somewhere, right, on the x-axis. The x-intercept has a y value of 0. Every x-intercept ever has a y value of 0. So we're going to plug in y equals 0 to our function to find the x-intercept. If I plug in 0 for y, I'm going to find the x-intercept. So this would be 2x minus 6 times 0 equals 12. Now when I plug in 0, negative 6 times 0 is just 0. So that part is gone, and I only have x left. I've got 2x equals 12, so I'm going to divide both sides by 2, and I get x to be 6. That's my x-intercept. Now I'm going to find the y-intercept. So to find the y-intercept, I'm going to plug in x equals 0. The y-intercept happens on the y-axis. The value of x on the y-axis is always going to be 0. So I'm going to plug in 0 for x to find the y-intercept. So this would be 2 times 0 minus 6y equals 12. 2 times 0 is 0. So I just get negative 6y equals 12. I want y by itself, so I'm going to divide both sides by negative 6. And I get y to be negative 2. I want you to notice that's the same y-intercept that we found over here. Okay, so I'm doing a lot of the same, or I'm finding, I should say, some of the same things. I'm just finding them in different ways. Question? Could you just do like this part of it? Yeah. Well, remember, if I pick this strategy and I find the y-intercept, I still need to know either the slope or another point on the line. Does that make sense? So because we happen to do this one first, we have that information already. But if I picked to just use this strategy, I wouldn't know any of that other stuff. Does that make sense? Okay. So you could find the y-intercept first if you wanted to, and then find the x-intercept, or find the slope somehow. You would have to still have to do that other part. So once I know the x and y intercepts, I can plot them. So the x-intercept is 6. That means I cross the x-axis at 6. The y-intercept is negative 2. That means I cross the y-axis at negative 2. I have asked you guys to always give me 3 points for a graph. We have 2 right now. To find the third, I'm going to figure out the slope. Okay. So I'm going up 2 and over 1, 2, 3, 4, 5, 6. 2 over 6 I can reduce to 1/3. It means there's actually another point in between these. So I can go up 1 and over 1, 2, 3. Or if you wanted to, down 1, back 1, 2, 3. Again, I still want 3 points no matter which option you take. Okay. Once you have your points, connect them, throw your arrows on the end. If you prefer one option over the other, that's absolutely fine. But I ask that you remember that if you're kind of in the weeds, changing into slope-intercept form, there's another option that might be a little bit easier for that particular problem, okay? If you're having a hard time simplifying or finding your slope, or maybe your x-intercept is way off the graph, and so you're having a hard time graphing using this strategy, remember that, again, you have another option, okay? So it's okay to have a favorite method, but remember, flexibility is important. Questions for me so far? Okay. That's it for your packet. I have just a couple more graphs I want to go through with you guys. So if you want to sort of work through the changing the slope-intercept form or the finding the intercepts in some of that spare space down at the kind of bottom of your page, that would be great. You could even, if you want the practice, graph them on the coordinate planes that you've got there. Again, these are just a couple extra practice examples. So for our first one, again, we're going to do the same thing. I'm going to go through this using both strategies. So our first function is 4x plus y equals 0. So I'm going to start by converting this one to slope-intercept form for no reason other than it's the method that's on the left side of the page. There's nothing special about why I'm doing any version first. Okay. So remember, for slope-intercept form, I want y by itself. So I'm going to move the 4x to the other side. This would give me y equals negative 4x. What's my y-intercept here? Yeah, I'm used to seeing some number here at the end, and that's my y-intercept. If I don't see anything, then it's 0. So my y-intercept is 0 here, and my slope is negative 4. So I'm going to go down 4 and over 1. 1, 2, 3, 4, over 1. 1, 2, 3, 4, and back 1. So I get 3 points on my graph. Connect them, throw your arrows on the end. Not too bad? This one was pretty easy to change to slope-intercept form. Let's take a look at finding intercepts for this guy. So if I want to find the x-intercept, remember I'm plugging in y equals 0. So this would be 4x plus 0 equals 0. So I've got 4x equals 0, divide both sides by 4, and I get x to be 0, right? 0 divided by 4 is just 0. So I cross the x-axis at 0, and now I'm going to find the y-intercept. So I'm going to plug in x equals 0. This would be 4 times 0 plus y equals 0. 4 times 0 is 0. So I get my y-intercept is 0. Notice that matches what we found over here. So I'm going to plot this, and it's the same point. Now, I picked this example on purpose so that we could talk about what to do if stuff doesn't pan out the way that you're expecting it to. So in this case, my x and y intercept is the same point. So I didn't get 2 points. Since I don't have 2 points, I can't figure out the slope, right? Because we're pretending this doesn't exist. So I've only got 1 point on the graph because my x and y intercept were the same. So for this example, I am sort of forced to change it to slope-intercept form unless I plug in another value for x. So if I wanted to, I could plug in, let's say, x equals 1. And then solve for y. So this would be 4 plus y equals 0. Move the 4 to the other side, and we get y equals negative 4. That would work. So 1, 1, 2, 3, 4. Notice I also had that point on my other graph. Once I have a second point, I can find the slope. So I went 1, 2, 3, 4 down and over 1. So I can get a third point. 1, 2, 3, 4, back 1, since I'm out of room this way. So I had to pivot a little bit on this one. I expected to be able to have 2 points from finding the x and y intercept. I didn't on this example. Okay. Now, most of the problems I'm going to give you, you're not going to have any issues using either method. One may be a little bit easier than the other, depending on the problem, but I'm not going to give you a bunch of problems where you get kind of weird stuff like this that happens. But I did want to show you an example like that so that we could talk about strategies. What can I do if something like this happens? Questions for me on this one? Okay, so this one was a little goofy. Let's look at one that's not going to be goofy. So we have x minus 2y equals negative 6. For this one, how about we start finding the intercepts? Okay, we'll do it the opposite way this time. So our x-intercept happens when y equals 0. So I'm going to plug in 0 for y. That would be x minus 2 times 0 equals negative 6. Negative 2 times 0 is just 0. So I get x equals negative 6. 1, 2, 3, 4, 5, 6. Here's my x-intercept. And then for my y-intercept, that happens when x equals 0. So this would be 0 minus 2y equals negative 6. So I have negative 2y equals negative 6. Divide both sides by negative 2. And I get y equals 3. 1, 2, 3. I've got 2 points. Again, I always ask you for 3 for a graph. So I'm going to figure out the slope to go from one point to the next. I have to go up 1, 2, 3. And over 1, 2, 3, 4, 5, 6. 3 over 6, I could reduce to 1/2. So we've got a couple of points in between here. If you wanted to just go forward up 1 over 2, that would be fine. That's 3 points. That's what I asked you for. You can also find, again, those points in between. Up 1 over 2, up 1 over 2. As long as you have at least 3 accurate points, I'm happy. Connect them, throw your arrows on the end. The other option is to change it to slope-intercept form. So to change this to slope-intercept form, I need to start by moving the x term to the other side. So that would give me negative 2y equals negative x minus 6. Again, these are not like terms, so I'm not combining them. And then I need to get rid of this negative 2. So I'm going to divide everything by negative 2. That leaves me with y equals negative over negative would be a positive, and this would be 1/2. So 1/2 x, and then negative 6 divided by negative 2 would be positive 3. My y-intercept here is 3. 1, 2, 3. That's the same point we had on our graph using the other method. And my slope is 1/2. Same slope we found over here. So up 1 over 2, up 1 over 2, down 1, back 2 if you want some points this way. If I take it all the way to the x-axis, we get the same x-intercept. Connect your points, throw your arrows on the end. Questions for me on this last one? Okay, so from here on out, I don't care which method you use, okay? Pick whichever one you like best. Just keep in mind that for some problems, changing the slope-intercept form might be a little easier. For some problems, finding those x and y intercepts might be a little bit easier, okay? So have a favorite, that's fine, but remember, be flexible. For the rest of our class period, you have 2 assignments on Khan Academy. One of them is graphing from standard form, exactly like what we've just done. Again, use either strategy. And the other one is given a function, find its x and y intercepts. So you're going to see functions in all different forms. You're going to find those x and y intercepts using the same strategies that we use here. To find the x-intercept, we plug in y equals 0. To find the y-intercept, we plug in x equals 0.